So the first triangle we're going to talk about is the 45, 45, 90-degree triangle, and this is a self-exploration activity. Little a would be across from big A, little b would be across from big B, and then little c is across from little c when you're labeling these. But after you fill out this whole thing, you're going to start to notice a pattern. And the pattern is, and you could do that yourself, is that if this is 45 degrees, and that's 45 degrees, then technically this triangle is isosceles. And so whatever this is, like let's say that's the leg, which it is called a leg. If we know one part of it, we could fill in the other two parts. Well, if this is across from 45, then this has to also be the same thing. So in a 45, 45, 90-degree triangle, your legs will be the same. And after you do this activity, you'll find that whatever the leg is, you just add on a square root of 2. So it's x times square root of 2. That is the proportion. So in a special right triangle that's 45, 45, 90, if you're trying to find the hypotenuse, you just multiply the leg by square root of 2. And if you want to find the leg, if they give you the hypotenuse, then instead of multiplying, you're going to divide by the square root of 2. So here's an example. They tell me this is isosceles. How do I know it's isosceles? Because they tell me that two of these are the same. So we're supposed to find the lengths of the missing sides. Well, if that's 8, the marking here says that that's 8. But because this triangle is isosceles, we know if this is 90, that these angles have to be the same. So 3 angles in a triangle add up to 180. You take 180 minus 90, you're left with 90. They have to be the same. Divide that by 2. This has to be 45. So this is 45, 45, 90. Everything on this page is 45, 45, 90. Okay? Now what that means is we have a leg. The leg is 8. So if you want to find the hypotenuse, you find the hypotenuse by multiplying the leg by square root of 2. So what is the leg? 8. So up here you'll put 8 square root of 2. And I think I'm going to draw it this time. So you're going to put 8 square root of 2. Next, by looking at this diagram, 90, those are the same. These have to be 45, 45. So we start with the hypotenuse. They want us to find the leg. So you find the leg. You find the leg by dividing the hypotenuse by the square root of 2. So I'm going to take 5 square root of 2 divided by square root of 2. Square root of 2's cancel. So I'm left with 5. So this has to be 5. And so this has to be 5 too. On problem C, this is 45, 45, 90. If this is 4 square root of 3, we can see the legs are the same. So this has to be 4 square root of 3. So we know the legs. Now to find the hypotenuse, you find the hypotenuse by multiplying the leg by square root of 2. So I need to take 4 square root of 3 times square root of 2. I'll do it down here. 4 square root of 3 times square root of 2. This is part of why I spent today yesterday going over the properties of radicals, because from yesterday we have 3 times 2, those are called the radicands. You can multiply those together, and you can take 4 times 1, which is 4, so you get 4 square root of 6. So we know this is 4 square root of 6. Now, if you can reduce the radical 6, you should reduce it. You should simplify it. But 6, all that goes into 6 is 2 times 3. There's no pairs, so 6 is reduced. So here is my hypotenuse, 4 square root of 6. 45, 45, 90. This leg's 9 square root of 2. They tell us with the markings that this is also 9 square root of 2. I'll label it. So to find the hypotenuse, this is the hypotenuse, you take the leg times square root of 2. We have that in our notes up here. To find the hypotenuse, you multiply the leg by square root of 2. So I need to take 9 square root of 2 times square root of 2. When I'm multiplying these, it'd be 9 times 1. 2 times 2 is 4. So I get 9 square root of 4. But 4 could be broken into 2 2's. 1 2 comes out. So this is really saying, what's 9 times 2? 18. Because the square root of 4 is 2, 9 times 2 is 18. So this is 18. Okay, E. This is a square. If you take a square, and I know this is a square because it's 90 degrees, all 4 sides are equal. So if you take a square and you make a diagonal through a square, this is 45. So this is 45. And this is 45. Now, we want to find the leg, and we know that these legs are going to be the same. And so, how do I go from hypotenuse to the leg? Let's go look. You find the leg by dividing the hypotenuse by square root of 2. Okay? So I need to take 6 divided by the square root of 2. Now we learned yesterday, and it's called rationalizing, that it is not okay to have a square root in the denominator. This is not a correct answer. So how do you undo a square root of 2? Well, you multiply top and bottom by square root of 2. Or multiplying. If you multiply by square root of 2 over square root of 2, that's really times 1. It doesn't change anything. But here we get square root of 4. And square root of 4 is just 2. If that was square root of 3 times square root of 3, that'd just be 3. If that was square root of 4 times square root of 4, this would just be 4. The square roots cancel each other out. And then here, I have 6, that's not in a radical, 2, that is. This is not square root of 12. It is just 6 square root of 2. You cannot reduce 2 over 2 because 2 is in the radical, 2 is not. But I can reduce 6 divided by 2, which is 3. So this equals 3 square root of 2. So I can label this 3 square root of 2, and I'll just put an arrow for both. So I've done a lot of examples. F is just like E. If you're starting with the hypotenuse and you're trying to get the legs, why don't you spend a second and see if you could do F. That's probably the hardest type because you're going to divide by square root of 2 and have to rationalize. So I'll let you take a second and try F. So you can hit pause if you're watching this at home. Here we have 45, 45, 90. This is the hypotenuse. To find the leg, you divide by square root of 2. So I'm going to take 7 divided by square root of 2. It is not okay to have a square root in the denominator, so you multiply by square root of 2 over square root of 2. This is called rationalizing. Square root of 2 times square root of 2 is 4. Square root of 4 is 2. So the square roots cancel, just making a 2. And then up here, I have 7 times square root of 2. I'll just write those side by side. And then you try to reduce 7 over 2. 7 over 2 does not reduce, so this is the answer. So I'm going to take this, and that is the legs. And I'm done. And make sure you get 7 square root of 2 divided by 2. You might also see that written as 3.5, 3.5 square root of 2. You might also see it written like this. It's the same thing. You might see it written as 7 over 2 square root of 2. You might also see it written like this. But those are all the same thing. Because technically you could put the square root next to it. So those mean the same thing. You might see that written as 3.5 square root of 2. Or 3.5 square root of 2. All the same. So we have Kaminsky Park, and that's in Chicago. And it says BD, so from here to here, is if you were to go from home plate. So here's home plate. So there's first, here's first base. Here's third. Here's second. In AE, if you went from the left field foul pole to the right field foul pole, that would be AE. And if the center fielder is standing at point C, we have a center fielder right here, and that makes 90 degrees. How far is he from home plate? In other words, how far is he from here to here, which they labeled as X. So they want us to find that. And they tell us this is 347. They tell us this is 90. That's 45, 45. So in other words, if this is X, then this is also X. So we have a 45, 45, 90. To find a leg from the hypotenuse, you divide by square root of 2. So I'm going to take 347 divided by square root of 2. This is a problem where I would probably just type in my calculator 347 divided by square root of 2. I know it's not exact, but I don't think a person's going to want your answer as a radical when you're talking about a real life example. So if you type this in your calculator, you get about 245.366. And so if I'm talking about distance for something like this, nobody's going to care about the radical in this kind of problem. On your practice, make sure you keep it as a radical. And I'm not going to say 245.36. I'm probably just going to say 245 feet. So I'm going to say the center fielder is 245 feet from home plate if standing at point C.